common question I get asked is, what do you look at first when you try to identify a plant or a tree? And that's really a tough question. I like to compare it to seeing somebody when you pass them on the sidewalk. What do you look at first to determine whether or not that's somebody you know? Or have you ever seen somebody from afar and you think it's somebody you know, only to find out that it's not? What do you look at to know? And it's kind of the same way with plants. With plants, we look at the whole thing, and sometimes we look at the individual parts and unique physical features to try to make that determination. With a lot of species of conifers, sometimes we're going to look at the whole plant and know right away what it is, and sometimes we have to get up close and examine the individual parts. Some of the things we're going to look at are the needles, the shape of them, how many there are they in bundles or are they individual? If we're able to look at the cones, that's sometimes helpful. Sometimes just how the overall tree is shaped, how it's growing, any number of features to help us identify exactly what it is. We're looking at a Norway spruce here, but before we start talking about this tree specifically, I'd like to point out a few general features about many of the conifers that we're going to be looking at. Often people mistake the leaves of a conifer as being a compound leaf, and they are not. Each needle is an individual leaf, and the structure that they grow from is the stem. The needles on a conifer can grow off of several layers of stem. So if we look back here on stem that's a few years old, it looks a little funny with the needles coming off of the thicker stem, but you can see that they do so just fine. The way the needles come off this stem is no different than the way the needles come off of this stem. The only difference is that stem is a little bit older than this one. Now, as we look specifically on spruce, the way the needles attach to the branches is a little bit unique from other trees. We have these tiny little structures called pulvini. It's like a little peg that holds the needle in place. And as the needles fall, or as the tree loses its needles, the pulvini remain. Another feature specific to spruce is the shape of the needles. Now, different species of spruce can have needles of various lengths, but if we try to pull one off here, it's hard to see it on the camera, but they're very square or rectangular shaped, and it's almost impossible to roll them in your fingers. On all species of spruce, you'll find that the needle is attached to the stem on a pulvini, the small peg-like structure that I was just telling you about. All spruces, the needles are kind of square or triangular, very difficult to roll them between your fingers. I don't see any cones on any of these left over from last year, so I can't really point out to you, but on a spruce, the cones hang from the branches downward. While all spruces are going to have those same basic features, telling the different spruces apart can sometimes be a little bit challenging. Often we have to look at the different features of the cone. However, on the Norway spruce, its telltale sign is the drooping, cascading branches that the needles grow from. Here's a good view of how the branches droop down. That is thought to be an evolutionary advantage to help the tree shed snow. As we look up the tree from the ground here, we can see how it would be very difficult for snow to accumulate on the branches. Right here we're looking at a white spruce. It's fairly young. We're looking at the lower branches. These branches are probably 5 or 6 years old. And you can see on the newest branches here, these needles, they were probably new from last year. As we come along down here, this section is probably from the year or two before. 3 and on back there would be 4 or 5 years. And as you can see, it is still retaining most of the needles. We know it's a spruce, because the needles are individually attached. They're square, we can't roll them in our finger. We can see the pulvini from where they were attached. Now, when we have a conifer with singular needles like this, sometimes it looks a little funny when we look at the older needles along the older branches. These are attached and they make us think that they are simple leaves. But when we look at these newer ones, when this is new green growth, you could almost mistake this for a compound leaf. So on our singly attached needle conifers, sometimes they can trick us into thinking that they have both simple and compound leaves. This small white spruce is probably 3 or 4 years old. And to be quite frank, it should have been rejected. If you look up here, we have 2 main leaves. This is not the same tree. This is 2 different trees. When it was propagated, it was done so incorrectly. This one was probably propagated by seed, and there were probably 2 seeds that got started, and they've stuck together. It's growing fine for now, but within a few years, the 2 trees are really going to start competing with each other, and they're both going to look less than exciting. Well, one of the things we look at to identify the trees is the overall form and the way that it grows. In the case of this blue spruce here, you can see that the environment can influence it so much that often we get some very interesting looking trees, and so the overall form isn't always the most reliable indicator. There's some leftover cones on this blue spruce, and we can see how they hang down from the branches. That's one of the easiest ways to tell from a distance a spruce from a fir. With a lot of hybridizing and crossing of different species, we get something like this, where we have the weeping habit of the Norway spruce, but the color and texture of a blue spruce. We know it's a spruce because we can see the pulvini that the needles grow off of. And if we look up higher in the tree, we can also see the cones are hanging down. Maybe it's a mistake, maybe it's on purpose, but this spruce is a blue spruce, and this is a white spruce. I can see this small conifer is conical shaped, and from this distance it appears that the needles are attached singularly. So immediately in my mind, I've already narrowed it down to probably a spruce or a fir. Let's get a little bit closer look and see if we can figure it out. As we look closely at the needles, we can see that they are flat, narrow, do you see how the needles attach? They flare out at the bottom and it almost looks like a suction cup. This is a fir. As we look through the foliage to the main trunk, we can see that the bark is gray and smooth. And the farther out the branches we come, the grayer they are. We don't have any cones to look at. Cones are very helpful in identifying the different types of firs. But the grayness of the bark and the smoothness of the bark, I'm going to say this is most likely a Fraser fir. As with all the other conifers we've looked at, we can see needle retention for several years worth of growth. As we look at the color of the bark, we can tell the different years worth of growth. The outermost is the most recent. These needles are 1 year old. And as we come back this way, these needles are 2 years old. Probably right about here, at this junction of branches, is another year. These are 3 years old. And as we go back even farther, those are going to be 4+ years old. One additional item to note about the singularly attached needles on a fir: when compared to a spruce, generally they tend to be longer. This isn't always the case, so that should not be our primary identification. Firs aren't very common in Ohio, so we're really spending a lot of time looking at this one. The way cones grow on a fir is the opposite of how they grow on a spruce. On a spruce, they hang downward from the bottom of a branch. But on a fir, they stand up on top of the branch. I did end up finding what's left of a cone on this Fraser fir. This reddish structure here. It just looks like it's debris that has fallen from another tree. But as we look around, we can see that it is connected to the branch. And if we come back just a little bit, we can also see that it is coming off of the top of the branch and it stands up. This cone is probably at least 2 years old. This is what's left of it. This is the main central support. You can see what's left of some of the scales. As the cones mature and age, the scales individually fall off and blow away and scatter the seeds. I was thoroughly looking through this tree for some cones or for some evidence of cones past, because I'm sure it's old enough to have had cones by now. But as I was looking, I found this. It looks like part of the tree, doesn't it? It looks like maybe a small broken branch with dead needles. It's not. This is a bagworm. This may or may not be a test question. As the bagworm spins its cocoon, it does use parts of the plant that it's on. And so those are dead needles, but it's not a result of the branch being broken, but it's a result of the bagworm larva pulling the needles off of the tree to include them in the structure of its cocoon. Sure enough, there's another one. Here's another conifer along the trail. I'm gonna walk up and see if we can identify this one also. And from here, if I'm looking, I see flaky bark, grayish towards the bottom of the tree, and it gets a little bit more orange as we go up. Thick, heavy needles in bundles of 2. The needles are flat, and if you look along the length of the needles, each one of them twists. That flat surface twists along the length of the needle. This is a Scots pine. Scots pine thrive in bad soil, which means when they grow in good soil, there's always too much competition from other plants and they usually get choked out. That's probably going to be the future for this guy in a few years. As we look at this tree, it appears to be a Scots pine. We can see the brightly colored flaking bark, especially on the lower ends of the branches and the trunk here. And as we look at the needles, we can see that they are in bundles of 2, that they kind of have a flattened surface, and that flattened surface twists along the length of the needle. As we look through this small landscaped area, we can see some white pines and Scots pines along here. The Scots pines aren't doing so well. They're more salt tolerant, so it's not the salt from the street. Most likely it's just because they don't compete very well. Scots pines do much better in poor soil, poor growing sites, which is good if you have that sort of a site. But the downside, anytime they're around healthier, faster growing plants, they always get choked out and they don't get enough nutrients, and ultimately they just don't do well. And we compare this poorly performing Scots pine to these ones just up from it. I wouldn't say these are doing the best that they could be doing, but they're doing a lot better than this one over here. And really the most probable cause for that is the lack of competition from other vigorous growing plants.